Okay, a bit more lingo here. Lines in R3. This vector here tells you where the line is in space. Okay, it tells you that the line goes through, this vector, or the corresponding point, if you want. And this vector v tells you, well, what direction your line is going in. Okay, so for that reason, we're going to call this vector a direction vector. And likewise for a plane, okay, u tells me where in space my plane P happens to be. And then v and w actually give the, imagine my hand is a plane. It tells you what the orientation of the plane is, So it could be like this, or it could be like this, or like this, or like this. It's v and w that determine that orientation. And we still call them direction vectors because it's, it's not one direction, it's two directions, but together they give orientation. Okay, we're going to do an example here where we solve a system and interpret the collection of all solutions in a certain way. So this system will have an infinity of solutions. And we're going to find some new ways to think about that infinity of solutions. Okay, so first thing I want to say is that this is what's called a homogeneous system. Okay, all zeros. Okay, when you have all zeros over here, so you look, and you can't have any constants appearing. You can't have a +6 like appearing here. Okay, so all the constants are over on the right-hand side. If you have all zeros here, then we call this a homogeneous system. Okay, so to find a solution, I throw this into a matrix. Let's not get too crazy here. And 2, 5, 10, -1, 2, -5. Now, I have 0, 0, 0 here. In the future, when you get more practiced with these things, you don't actually need to put these zeros in your matrix because as I row reduce, they're not going to change. Anyways, so I will just skip ahead to the reduced echelon form. So I'll get all zeros underneath. Because this second row is just twice the first row, and this third row is just the negative of the first row. We have a pivot. First column is a pivot column, so this is a basic variable. So x equals basic variable, and then y and z, their columns are lacking pivots, so they are free variables. Okay, so to solve such a thing, I'm going to write out, basically what I have left here from my reduced echelon form. I have x minus 2y plus 5z is 0. And then I will solve for my basic variables. Solve for my basic variable. And in some cases, you'll have more equations. Not this case, but in some cases you'll have more than one basic variable. And what does that give me? It gives me x is equal to 2y minus 5z, and then y and z are free. And this right here is what we call the general solution. So it tells me that any combination x, y, z that passes all three of these tests is of this form. Okay, y and z can be whatever you want, but then once they're chosen, x has to equal 2y minus 5z. Okay, we'll come back in the next video and talk about some geometry here.